that? Everything has logistics, that's right. All right, so look for those missing words. So I got to choose this textbook. I think he does a good job, Lucas does. And one of the things is weather can be very eye-catching, very dramatic, right? You're like, oh, so glad that's not me. Looks like those cars aren't going anywhere. So there's all sorts of reasons we want to know the weather, and one of them is safety, okay, including don't get frostbitten, right? Is that why they canceled school a few days ago? Yeah. But you know, you could be planning your vacation and want to know where the nice skies are going to be. Some of us chase thunderstorms, or some of us, part of us, are volunteer work or part of our job. You know, go out there and be the hands and the feet, or guess the eyes on the ground for the folks who are forecasting the weather. Okay, so this severe stuff, it's coming. I mean, it's probably coming literally, but it's coming in the course. We'll be talking more about that. But we need to talk about the Earth's atmosphere to understand the severe stuff. So this is actually just kind of a, I think it's, you know, copyright 2013, but it says up to, from 1980 to 2010, two things. The blue things are the number of events for that year, and the red things are the dollar amounts. And if you're like me, it's interesting where sometimes there's not that correlation. So anybody remember when Hurricane Katrina was?
2005.
It was in 5, that's right. So if we focus on 5 right here, okay, actually there's more damage in billions of dollars than there were a number of events. Okay, in 2008, lots of events, low on the money scale. Okay, some quiet years. You know.
Was Hurricane Sandy in like 11 or 12?
I can't remember. One of the things, I bet Wikipedia knows. And you already know that they're alphabetical when they name them. So Sandy was just after the R hurricane, and they alternate girl and boy now, men and male and female names. And when a hurricane is nasty like that, that name will be removed from the list. There's like 6 lists, okay? And that name will never be used again. It's retired. So that's about hurricanes. So this is a different look at kind of the disasters that weather brings. I was looking at this at my desk, and to kind of get your bearings, and I actually have some more information coming, but it starts with, it ends in 2007, okay, and it begins in 2002, and they are just listed chronologically. Okay, so that helped me to get my bearings. So you mentioned Katrina. Okay, yep, there you go, Katrina. Was it August? I thought it was August. Okay. And that same year, Dennis. Okay. After Katrina came Rita. It's always a bad year. And if you've read that we can have a bad year for hurricanes, you're right. It's related to a lot of different factors, but they think they can predict it in part by looking at the El Nino La Nina pattern. So we'll be talking about that. So this link down here, and I think I went ahead and pushed this out to my Twitter feed, but I was like, well, what came after 2007? So out there is another website where they have gone ahead and, at least to 2014, with kind of just a paragraph now. It's not in the same table form. One of the things as I was looking at this, notice that a weather disaster, droughts are a weather disaster. People can die from heat waves, not necessarily related to droughts. Okay. Oh, I guess it's the 2013, not 14. But, so like I said, this link's available under the Twitter feed for this course. But it's interesting when you're like, oh, I remember that. That's terrible. Okay? We've definitely had our fair share of tornado. Sometimes tornadoes come in groups. Okay? Tornado outbreak. Sometimes you don't need a tornado outbreak, just an F5, an EF5 tornado to be a bad thing. So it's all fun and games till somebody gets hurt. So that's just kind of the wow of weather. Okay, so meteorology is the study of weather, but more generally it's a study of the Earth's atmosphere. I guess it doesn't have to be the Earth's atmosphere. Because out there, if you look for weather on Mars, actually there's a rover out there that's telling us the atmospheric conditions of Mars. Okay. If you ask for weather on Jupiter, there's no rover on Jupiter. Okay, but definitely Jupiter has those thick clouds. It has some interesting phenomenon, we think. So there's weather on other planets that has an atmosphere. So the Earth's atmosphere, based upon the Earth's size, is just kind of a, and I have some pictures here to show you kind of how thin the Earth's atmosphere is compared to the Earth. It's like, oh my gosh, is that really all we got between us and space? Yeah. Okay. And it's related to the Earth's mass. The smaller the mass, the less the atmosphere because the gravity is not so strong. The moon doesn't have an atmosphere. It has more of what they call an exosphere. So the moon is kind of oozing gases. Okay. So another thing with regard to the atmosphere, we have the day-to-day weather, and then we have the long-term average of the condition of the atmosphere called climate. And we are all, I think, not as careful as we should be by saying there's a change in climate by just actually saying, well, there's something weird going on with the weather. It's said, and you see I guess you don't see it up here, I'll add it. 30 years basically is how you need to track to get a fix on the climate. So this is about a 30-year average. It's a rolling average. Well, that's a long time. There are models that are forecasters that do on the news. There are models that they say to what's going to happen tomorrow in the weather. Okay. There are also models that says, looking based upon what's happened in the climate, what's the future climate going to be? If you've ever seen The Day After Tomorrow, yeah, he was like the model guy for climate. Okay. All right. So here is a bunch of stuff. Some of this stuff you were writing down on your weather log. Okay, so when we went to do your weather log, you guys wrote down temperature, you wrote down current humidity. What's humidity? What do you think?
The amount of water.
Moisture, water in the air, exactly. There's like at least 3, if not 4, if not 5 different ways to express water in the air. So we'll talk about humidity later, but yes, it's just water in the air. Cloud cover, it's kind of cool because basically these things are done oftentimes remotely, okay, using, I'll go ahead and give you the acronym, Aerosols. So like when you get it off the internet, an Aerosos is remotely giving you all that information. So cloud cover and amount can be detected in these little gizmos called Aerosols. Is it precipitating? What's the atmospheric pressure? What's the wind speed and direction? So yeah, I guess all of those, didn't you? Kind of on your weather logs. So here's a colorful weather map, and we'll be talking more about this. What is the blue line, you guys? It's not the jet stream. It could be, you know what, to me, possibly the jet stream is kind of dipping down there. You can kind of see because the cold temperatures. So we kind of have it implied in the temperatures that the jet stream's kind of dipping. But what's the blue line right here? A front, a cold front. Very good. It is cold front. Red line? It's another front. Hot front. Warm front. Very good. And on black and white images, how can you tell that, what's the difference? Exactly. The triangles would be the cold front, and the semicircles would be the warm front. Or in case you're colorblind, or it's a black and white chart. Very good. Okay. I would call this kind of a mixed map. Mixed map, because it just kind of has an assortment of stuff on it. So this is another weather map. It looks a little more sophisticated maybe. Okay, these green lines are, let me go ahead and do two things right now. The green lines are showing you barometric pressure. And I'm going to go ahead and kind of get the ball rolling and show you in case you're kind of, now how does that work? I'm going to change to green. See if this, no, change to purple. See if this works up. You guys see these numbers at the top here? Those numbers? Okay. See how they're kind of, those numbers are kind of lined up on a green line? All right. So let's pick on this number, 1004, corresponds to this line right here. And so what that means is every location on here has a pressure. Remember when you guys wrote down the number, what did you guys write down for pressure? 30.09 inches, yeah. Okay, so this pressure is the same thing but in different units, okay? Same thing. And so that 1004 actually is in millibars. I'll put MB for millibars, but it's the same, it's similar to inches. Okay, so just another pressure. That's what those green things are. Okay, what's the red line? Warm front, very good. Blue line? Cold front, exactly. All right. Kind of a busy map, isn't it? And so then do you see these locations that have these little icons? Okay. These actually, and at the top there, oh, actually it says station models. Those things I've circled are called station models. So basically in one little spot, they're an icon that says a lot of information. To me, if I had to unpack any of that stuff, I'd have to have, and we'll look at station models later, but I'd have to have a key. Say, what the heck? But one of the things I want you to look at just for now are things that you two things that you recorded on your weather log today. The current temperature and the dew point temperature, okay? So what is the current temperature in Des Moines?
44.
Very good, 44. How many degrees do you need to cool it down to in order to get to dew point temperature?
36.
To 36 degrees, 38, I think it's 38. Yeah, looks like that. Okay, 44 and 38. So that's that. And you know what? Before computers, they used to do this all by hand. Can you imagine? Oh my gosh. We are so spoiled. Okay. So, sort of, it seems like we're kind of departing from the study of weather, meteorology specifically, to kind of talk about the scientific method. And I think all science classes should talk a little bit about the scientific method. I went ahead and pulled up a diagram that I think summarizes the scientific method pretty good. But tell me some key words to the scientific method. Which is more found in a hypothesis or a theory? Which one has more? Which one is probably more firmly correct?
Theory.
The theory, yeah. The hypothesis sometimes we call as a best guess. To me, the scientific method is just, oh, that makes sense sort of thing. It's like, keep looking at it till you think you're right. Okay, so your textbook covers this too, but you basically start out with sometimes you've heard a hypothesis called a best guess, okay? Based upon something you're curious about, okay? Then your best guess, you're like, hey, if I'm right, then you push the hypothesis to predict something, okay? And then you check to see if your predictions are right using tests, okay? And if they're right or consistent, you eventually can, and it's kind of like getting to your opponent's side in checkers, you get to become kinged. It's like taking a hypothesis, and going across the board, all these other scientists are trying to shoot you down because they're a bunch of little kids. Okay? But if you go ahead and survive the scrutiny, everybody trying to prove you wrong, because I bet there's money in proving you wrong, okay, then you get to, your hypothesis is king to theory. If it's not, if your tests fail, okay, then you need to adjust your hypothesis. Okay, so that's it. Keep calm and use the scientific method. Great. So sometimes on my tests, I will go ahead and, include the terms theory or hypothesis, theory, scientific method, kind of make sure you kind of know what it is. I went out today and just added a few slides. So these slides you don't have, but I thought they were cool. Okay. So this is just another look at the scientific method. Okay. One more.
We went forward one.
I did what?
We bumped forward one, just so you know.
I skipped one?
Yep. We were on that one and then you bumped forward.
Did it by accident or something.
Okay.
Yeah, as you were passing on the paper.
Oh, thank you. So this is very similar. You're welcome.
Thanks.
You're welcome. And so they used to, or I guess they still do, but each discipline, like physics, a discipline of chemistry, a discipline of biology, all the science disciplines. The soft sciences would be like psychology, sociology. Those are sciences too. They're just soft. That's what I've heard that called. They have their own little journals, not little, but they have journals where you publish your hypothesis, you publish your findings, and that's where you get to maybe be shot down. Okay. So I just kind of got some things off the internet. I like this one. So it's kind of in a cartoon form. Some of these don't actually take it beyond the hypothesis form. They just kind of say, come up with a question, test it. You know, if your hypothesis, if your test pass, you go ahead and test it some more. Okay. I went ahead and included this as the last slide. So here's the deal. You know, you guys told me, or you guys would, you guys know now or did already know that a hypothesis is, I'm just going to put guess. It's more than a guess. It's based upon your observations. Okay, that's an E. That's guess. Yeah. Okay. One more time. E-U. No. Dang it. See, this is why I'm not an English person. Okay. Best guess. Okay, and theory, I'd say proven, but you know what? Do you think theories can be disproven? They can. It takes it can be done. Okay. But then there's this other thing over here that might be confused a little bit. You might want to take an observation and take it through the scientific method in the form of a theory and then elevate that theory to, you might want to take it, start with a hypothesis, some sort of observation, and then take it to the status of theory. But a law cannot go through the scientific method because a law just is. And I should have brought a list of laws. What's that? Laws?
Newton's 3 laws.
Yeah. Newton's 3 laws of motion. Yeah, that's just how stuff moves. In chemistry, we talk about the gas laws. That's just how gases behave. There is no observation and come up with a hypothesis and test your hypothesis and elevate it to a theory. It just is. Exactly. Thank you. All right. So now back to your slides. Dun, dun, dun. So I'm going to click on this eye here in a minute, and it's actually going to show you a map where these little observing stations are. So Aerosols stands for Automated Surface Observing Systems. And I already alluded to these when I said they basically remotely get this information to the atmosphere and they push it out. Most of these Aerosols are, and I always think of spaghetti sauce, not the Aerosols. Most of these Aerosols are associated with airports, because they need to know what the weather conditions are. Okay.
That airports are in big open areas.
That's true. That's true too. Good place to avoid the urban island heat effect. So here is the Aerosols site. And you can see that at the top there, well, you can't see it, but it's National Weather Service, NOAA.gov//Aerosols. Okay. But one of the things that I got tickled with is I go down here at the bottom. This is the map I want to show you. It says new map of ASOS locations. Dude, that thing's been there for like 10 years. Maybe they updated it, I'm not sure. But let's go ahead and go for Iowa. And let's see where those measuring stations are. Oop. And as I'm rolling on my mouse, it's zooming out or zooming in. So the color here, you see that actually, let's see if it, there it goes. Keokuk and Fort Madison are green and Burlington is gray. So at my desk, I was like, okay, what's the difference between the color? Well, if you look at the bottom of the page, it says that instead of being an ASOS, an ASOS, actually the one in Keokuk and Fort Madison are AWOS. Okay, they're green. And I was like, all right, what's the W instead of the S mean? And the W means weather instead of surface. So I don't know if you all necessarily want to know this tonight, but did I just? I must have. I don't have a link here. I was trying to think if I did a link. Nope. There's not much of a difference. The ASOS is a little more complicated than the AWOS. But they're cool. And here's a picture of them. I think this one's from your textbook. Oh, go back. I think this is a figure from your textbook, where it has all these devices lined up sending that information, okay, for that one location. That's, like you said, in a nice open area. Okay. So then inquiring minds my mind wandered before class, and I was like, okay, so the NOAA stands for National Oceanic and Atmospheric Administration, right? So I was like, well, who does it fall under? I thought it fell under NASA, but I guess it doesn't. They do some joint atmospheric projects. But it falls under the Department of Commerce. Oh, that can't be a good thing. I know. Ew, I know. So what's under NOAA? Well, if you go to the spotter trainings, the folks that are going to train you are going to be the NWS people, National Weather Service people. Okay, they're really nice. Okay, and also under NOAA are the ocean fisheries, satellites. You know, you can kind of see. So this is just another look of what's under NOAA. Kind of these are basically these. So I don't know. Okay, back to your notes. So if you saw the movie The Day After Tomorrow, and not in just that movie, but other movies, the scientists go and dig up a core. Now, it could be an ice core like this, or it could be actually a core from the sediment of maybe the ocean, the bottom of the ocean, sediment core. Okay, but these are ice cores, just like oh, no, they aren't. These aren't ice cores. These are sediment cores from the ocean floor. So you know the way they work, right, is if this was the top, okay, if this was the top, this would be new, okay, and then you're going back in time, okay, like that. So you can find out all sorts of things kind of in this layered sort of situation, what sort of organisms were there. You can actually do an assay on gases and things like that. Okay. So we have the atmosphere, but we have some other spheres, and you probably can kind of tell what they mean. The geosphere, I go like this for the geosphere, that's the Earth. The atmosphere is the gas that's connected to the Earth. The hydrosphere is the water that's hanging out here. I still think the current theory is that the water associated with Earth came from, anybody know? Was it aliens or comets? Comets, yeah. So they think. Oh, comets that were sent to us by aliens. Oh, I hope not. So that's the hydrosphere. And we'll talk about the water cycle, the whole, the rain, and then the water evaporates back up, and it condenses in clouds, and it rains again. Yeah, that's the water cycle, the hydrological cycle. But hydrosphere is just water associated in the atmosphere or the geosphere. Biosphere is the life that's anywhere. Okay? As you might imagine, none of these spheres is in and of itself. So what your author does is kind of a series of slides to show these different aspects of the Earth system kind of interacting. So you see the hydrosphere, oceans, the geosphere, okay, and perhaps even the atmosphere, kind of with the spray, the ocean spray kind of going on. Well, with regard to the hydrosphere, so the water, okay, the water in the Earth, actually I think this is water just associated with the Earth. You probably already knew this if you watched many movies, that most of the water on Earth is salty water. Okay, most of it's tied up. Less than 3% is fresh. But we're going to take a look at that 3%. Of the 2.8 or less than 3% that's fresh water, 2.5% is tied up in glaciers, solid water. Like, dude, that can't be good. Okay, so 0.62 is groundwater, and that tiny little sliver right there, okay, is probably water that you see on a day-to-day basis. So it's not a lot. So here's a pretty look, kind of, it looks like a sunset or a sunrise, doesn't it? Kind of looking at the horizons, you know, kind of the Earth's atmosphere. So if you look at the Earth, look at the horizon, you're going to see layers of the Earth, and we're going to talk about the troposphere, and that's one of the layers of the Earth's atmosphere. So you don't have this slide, or these next few slides, and maybe it's just one slide, but I kind of wanted to give you a sense for if that kind of dark thing is the Earth, what does the Earth's atmosphere look like? The skin of gases that envelop the Earth. So that's taken by the International Space Station. This one's taken by one of the space shuttles, Atlantis, sun rising. And I'm not sure what took this one, but it's accredited by NASA. So the atmosphere, we kind of take for granted, right? We're lucky we have it, but it's really kind of tenuous. So back to the whole sphere thing. Remember the biosphere is life. So you definitely see life in the trees and life in the fish, okay? And of course the trees are in the air, so they'd be atmosphere, and the fish are in the water, so they'd be hydrosphere, kind of the interactions going on there. So I'm going to play you this brief video of a mudslide, okay? But mudslides are generally caused by prolonged precipitation, so hydrosphere interacting with the geosphere. I had a friend that was from Japan, and she said that in Japan that you could not pull these bushes because the bushes were, it was like a crime, because the bushes were keeping the, like mudslides and things from happening. So So here's another couple videos I'm going to play for you. Okay, Mount St. Helens. So Mount St. Helens, like the caption down here says, actually the volcano, right, Mount St. Helens, is the geosphere, but it definitely has consequences with the atmosphere. You guys might remember aerosols do a few things. One is they can, if they're thick like that, they can block the sunlight. And what does that do to our surface temperatures? Drops, exactly. The other thing aerosols can do is provide a surface actually for water to condense. They can actually promote clouds, promote precipitation. Okay, and precipitation hopefully can clear the particulates from the air.
Aren't aerosols flammable?
Not all aerosols are flammable. All the word, they could be, but aerosols in general just means it's suspended liquid or particle. Yeah, and we're kind of used to taking our cans, you know, and there's an aerosol in there, and you, so basically that mist that comes out is the aerosol. Yeah.
I was wondering, because I worked at a distribution center, and they had to have a separate brick ring for all the
It could be that the ones there working with are flammable. Okay. So, stuff of the atmosphere. That's what that's one of the things we need to cover. So they fall under two categories: permanent gases and variable gases. Sounds like a good test question. Okay. The word variable kind of gives it away for the second kind we're going to look at. What do you think variable means?
Varies.
It varies, yeah. Its concentration isn't the same. These are permanent gases, and their concentration is pretty much the same. In this room, I told you a minute ago, most of the air particles, gas particles hitting you are nitrogen. And this is one of my favorite test questions, because sometimes a misconception is, since our bodies need oxygen to survive, we think that most of what you're breathing in is your gas is oxygen. It's not. Okay, it's only about 20%. Okay, so these top three, I wouldn't have guessed argon if I was y'all. Okay, but nitrogen, oxygen, and then argon, kind of the top three. Okay, they pretty much in this close to the Earth's atmosphere, that's the composition. Then we have trace gases. Okay, but again, permanent because their concentration is basically permanent. These are, I guess it's not good. So this is the same information in pie chart. Okay. So variable gases. What sort of gases do you think? I can't remember what this is on here. Let me look over your shoulder. Yeah, you can already see the variable gases there. Okay. So water varies a lot. Deserts versus tropics, right? Okay. Depending upon where you're at. But does the water for a given location vary? Yeah. And again, we're talking about water in the atmosphere now. We're not talking about water in the atmosphere. Okay. Another gas that varies by location and from day to day is carbon dioxide, variable gas. And yes, we are going to talk about the trend in the amount of this variable gas, carbon dioxide, increasing. Ozone. We're going to talk about ozone. It's another variable gas. It varies at the same location from day to day, and it varies from location to location on a given day. But there's good ozone and bad ozone. I'm going to talk about good ozone and bad ozone. Usually we talk about the good ozone that's being depleted, right? But there's also bad ozone. Okay, starting with carbon dioxide. We'll talk more about water in the atmosphere. We'll talk a lot about water in the atmosphere. Okay, but carbon dioxide in the atmosphere. Okay, the carbon dioxide that's floating around in the Earth's atmosphere came from the Earth burping. Okay, it's a cool story. If you read basically the formation of the planets, including the Earth early on, the Earth was molten. Okay, it solidified, formed a crust, and then at some point the gases that were trapped inside, okay, came out and became the Earth's atmosphere. Okay, so it burped those things. That's what I say. But some of the carbon dioxide in our atmosphere comes from human activity, most notably burning stuff, most notably burning fossil fuels, petroleum products to get around for our energy. Okay? Anytime you burn anything, you burn a tree, you create carbon dioxide. Okay? Carbon dioxide comes from burning stuff. So there are two ways of getting carbon dioxide in the Earth's atmosphere. Okay? As you may or may not know, carbon dioxide is removed from the atmosphere by plants. I bet you knew that. Did you guys know that? Okay. Plants, green plants basically are green because they have taken in carbon dioxide, have a little video coming up, and made sugars and stuff out of it, taking carbon dioxide out of the air. And then what do they give in return? What gas do they respire? Exactly. Plants are awesome. The other thing that you may not know, but another way we can get carbon dioxide out of our atmosphere, and it happens all the time, little crustaceans are very happy about this, is carbon dioxide goes from a gas, it bubbles into our oceans. And the reason crustaceans like it is they need the carbon from the carbon dioxide gas to make their little shells. Isn't that adorable? Yeah. Okay. So I don't know if anybody, yeah, you got some pop there. That basically,
Rotation.
it is. That basically, pop is what I'm talking about here. Okay. So this is a figure from your textbook. I think it does a good job, okay? We talk about sinks and sources as it relates to the atmosphere. So an atmospheric source would be basically one of those up arrows. So sources of carbon dioxide are here. Okay, this is how we get carbon dioxide into the atmosphere. Okay? Those are sources. And then sinks are the down arrows. That's how we get carbon dioxide out of the atmosphere. I missed one. So I was looking for a good video, and I think this is a good video. See what you guys think. Okay. All right. So carbon dioxide, again talking about it being variable. It's variable in two ways. The notorious way is, and I'm going to show you that here in a minute, that actually from year to year, the amount of carbon dioxide in the Earth's atmosphere is increasing. Like he said, the carbon is building up in the form of carbon dioxide in the Earth's atmosphere. But the other thing you may not know is that for given location, it actually varies throughout the year. You're going to kind of see that wiggle here in a minute. And it has to do with plant activity. There's a delay in plant activity sucking in the carbon dioxide. So, you think of spring as plants, okay, but plants are just getting started. So actually in the springtime, you're going to see that there's a fair bit of carbon dioxide there for the plants to suck in. Okay, plants aren't at their most. Plants kind of have the most impact in the fall. So carbon dioxide is basically sucked down because of the plants. So we have in the fall we have a minimum, in the spring we have a maximum with regard to carbon dioxide. Okay, so that's kind of the yearly swing. Okay, and then the year-to-year increase. Okay, it has to do with burning fossil fuels, and then maybe you've heard this kind of confounded effort that this confounded effort that humans do when we go ahead and take large forests and down them for their wood. So then what happens is we have removed a sink source. Basically all those trees cannot remove carbon dioxide from the Earth's atmosphere. So that has an impact of increasing carbon dioxide in the atmosphere. Okay? So this is each little wiggle, each little blip is a year, okay? And what you're looking at is a project that was started clear back, before 1960 on one of the Hawaiian Islands, okay? And somebody volunteered to go ahead and measure the carbon dioxide in the atmosphere every day. Okay, so last year about this time, I know that this research center that's been measuring the carbon dioxide in the atmosphere at that one location was actually under scrutiny for needed funding. So I think it must have gotten funds because I went to it this year and it's still there. Okay. I know, right? So I'm going to take you to the latest data right here. So this is those happy people gathering data. See, notice January 12th. I thought it did. I thought it was today.
Isn't Mountain Low where the giant telescopes are as well?
I think so. The Keck Observatory? But yeah. Where is... I guess this will have to do. I was thinking in my desk that it had the January 15th, but this is close enough. So that is, I clicked, that was the day. This is the January 8th, 9th, 10th, 11th, 12th, 13th, 14th. Okay. But what gets more interesting, that's like a week. Oh, the suspense. Here's the month, and you kind of start to see May. But remember that we have the year, the seasonal swing. Let's go 6 months. I don't know. Similar. Okay, so that's carbon. This is all, those dots are carbon dioxide. Okay. This is the year. This is 1 year. I guess 6 months still would be part of a year, sorry. Still can't see a trend there. The year-to-year trend. We see 2 years. You can start to see the peak here, a little bit higher. Full record. And that's kind of what, this basically what you're looking at finally is what's in your textbook. The kind of squiggle is a year, and this goes from 1960 to 2015. So this is the increase in carbon dioxide for a given location. Okay. And then that's their data. And on their website, they also have clear back 1700s, okay, to current. So Industrial Revolution, wasn't it like late 1800s-ish? I'm not very good at history either. Okay, with the Industrial Revolution, we've been burning more fossil fuels, population increase, etc. So if you've ever heard the term hockey stick, okay, not hockey puck, but hockey stick with regard to increasing carbon dioxide concentration, this would be the handle of the hockey stick, okay? This would be the floor part of the hockey stick, okay, where it dramatically increases. Okay, let's see, back to, so there's 2 cycles for carbon dioxide. Okay, that's a good place to take a break. We'll come back and pick up with aerosols after your quiz. Okay, so I'm going to throw up here a quiz question here in a minute, but we still got like a 10-minute break. So 10-minute break, quiz question, and then we'll see how far we get.